Hello everyone, and welcome back to the continuation of our modeling, analysis, and design of reinforced concrete building structures. In this video, we are going to continue our series, so if you're a new viewer to this channel, please notice that this is part of a video series, an ongoing one, which I'll be linking on the top right. Check out the playlist if you want to know how we reached this place. Also, please notice that, as we said before, this is a video series which has an objective to try to explain to you how to model reinforced concrete building structures. There are some points where I said that, well, you should do it yourself at home. So those points are still remaining, and those points are still to be done by you at home. So please double check all the previous videos to know what were the points that were left for you to do. Anyway, today we are going to be talking about the foundation design. Now, the foundation design is a very long topic. I will try to split it into multiple topics: the spread footing, the combined footing, and the raft foundation. I'm trying to think of a way of doing piles, but so far I was unable to try to find that. I might even model a pile using springs and friction elements, but this is something that needs to be done later. I have to think about that. So well, today we're going to talk about spread footings, and with that being said, I hope you enjoy, so sit back, relax, and enjoy the show. Alright, so I'll have to run the analysis very quickly. Notice I have updated my Autodesk Robot to Autodesk Robot 2024, so we now have the latest and greatest Autodesk Robot. For those errors you have seen before, I have talked about them in the previous video. I actually went into details into how and why those are not really that dangerous. I might even need to do maybe I would do a video about the preliminary checks somebody should do while he is modeling, because there are some blunders people blunder, and there are ways of finding out those blunders. I'm just looking very quickly. There is an increasing trend in the axial force. I'm checking out the moments and why, just for one case, just to be sure, because I updated the structural model to Robot 2024. So I'm just making sure that everything seems to be right, and it seems to be right. So fantastic. Now, let's get into the design. Now, before I start, I want to quickly plug in multiple videos, and I will just mention that the design of individual elements has been covered in individual videos. Now, I will not be able to just list every single video on the top right. I will try to do that, but I want to mention that the analysis of the design of foundations has been covered in its specific video. However, we are in a structure, so why would I cover the topic again if we are in a structure? I will cover the topic again because, well, in structures, we have something called grouping. What I mean by this is, if I click this, for example, as a foundation, and just go to Design, Provided Reinforcement for Reinforced Concrete Elements, it will open for me the Design GUI. Now, please notice that the Design GUI in detail was explained in a previous video, which is just linked. So keep an eye on that if you want to have more information as of what is happening. Now here, I'm going to import simple cases, and I'm going to ask him to make me the combinations for me. I'll just click OK now, and I have it imported. Do I have it imported? Let me just check. Story 2. What's this? Those are maybe remnants from previous times. Okay, let's double click on foundation. There we go. Now, it's story 2. This might be a surprise for you. Like, how is it story 2 if it's on the ground, right? Like, this is a surprise for you. I see story 2, but it's on the ground, obviously. Well, notice this is basement 1, basement 2, so it's calculating like story 1, story 2. It's just a thing. You should definitely check out the series to understand why is this that you see. So I have the foundation. Of course, nothing has been designed yet, and I have no idea how it would look if I design it. So I'll just do me a simple blind calculation just to get the hang of it. Doing a simple blind calculation somehow reassured me, because I see 1.8 times 1.8 or something. Yeah, 1.8 times 1.8. And if I look like, yeah, for a 4-story building, this isn't the ballpark of what I'm expecting. Now, I just ran a random calculation. It gives me a tick. You can check out the results. You will see that this is the pressure of the soil. You will see that this is the reinforcement of the soil. And wait, what? Okay, now this is a problem that every time happens in Robot. Just click on the small and just drag it here. They still didn't fix it, it seems. It gives the reinforcement here, and if you click on any bar, you can see the details of the reinforcement, and you can go to the foundation note. Not only this, you can actually just go and show the drawings. And I think if you click here, it will show you the foundation drawings. Now, well, that's all nice and dandy, but okay, what happened, right? Like the most important part of it is what is happening. So let me go very quickly through the settings, just in case that you want a quick refresher of what those settings are. So I'm double clicking on the foundation, it opens me everything. I go to foundation view. Now here, generally, I have a spread footing, and I have seen, I think it was engineer Jesus Candia, our dear subscriber, he was having problems with combined foundation, and it seems that was a robot installation thing, because in some installations it seems you don't have this combined footing. So if that's the case, maybe you need to reinstall robot. But anyway, I'm giving him his full ability to change dimensions anyhow he wants. And of course, the dimensions here are basically based on the geotechnical pressures. Also, you have H4, which is the blending concrete. Some people call it the clearance concrete. Some people call it the sacrificial concrete. Tell me in the comment what this concrete that you put as just concrete for separation, what is it called? Not the concrete cover. We are not talking about the concrete cover. You can see that, of course, those dimensions have been changed because the foundation has been designed. If you want to get rid of the calculator, you just have to go to the preferences or go to tools preferences. I think I need to check out everything. And I think in general parameters, calculate and edit fields, just remove it. And now if you double click, it just highlights. So see, maybe you want to have the foundation 1.5. Now if you hit 1.5 and enter, it changes it and you have to recalculate again. Now lo and behold, it will get back to 1.8. Reason behind this is because you have not clicked on fixed. If you click on fixed, this means that it should not change 1.5. Which means that this one will change, will increase, and you can, wait, what? Okay, fixed 1.5, enter. Oh my, wait. And that's just run. Yeah, there we go. Maybe I did not hit the enter key or something. So you can see that this became 2 just to keep the area. Now, why would you play with the sizes? This is a very good question. I will show you some details later. What I mean by this here, if you go to structure and you enable the foundation, strangely it should appear. I don't know why it doesn't appear. Is this a new thing in Robot? I know that if you turn off and turn on, you should see, there we go, there it is. There is the foundation that has been designed. And you might want to limit some of those distances in the foundation, just in case if the foundation is neighboring or has some geometrical things or consideration that you need to consider. And I will be talking about this one in a moment, because those are 2 separate structures. You have a bridge structure and the structure here. So because there is a structural joint, and we will have to have 2 foundations here. I will talk about this in a moment. What I'm saying is that it's a nice touch in Robot that if you go back to structure and just hide and show the supports, you will see your design foundation. Okay, back to the foundation view. If you remove fixed, hit the calculator again, then it will just calculate back to 1.8 times 1.8. Fantastic. You have other things like the type of pier and optimization, for example, if you want to have without limits and so on. It's really cool. I've explained this in the previous video. How does it design? If you go to foundation results, you can see that all the combinations have been taken into account, be it design or service nodes. And okay, if it does do its accidental eccentricities and whatnot, of course the question here remains, based on what was the pressure compared? Now this is part of the inputs, and this here is like a typical reinforcement thing. If you click on that, you can define everything. Now I'm old school here, I don't use this. This is new in Robot. I'm kind of old school, so I like to define things from here. And if you go, for example, here, you can change the reinforced concrete strength, you can change the steel strength, the grade of it. Oh, I need to change everything, right? Because I have, okay, now what you see here is not what you will see with your Autodesk Robot. What happens here is just because I have installed a new robot, now all those settings have gone haywire. So what my guess is that the reinforcement here is in imperial units, although here I have millimeters, so this will freak out Robot. In case you have something like this, you can just go very quickly to preferences, job preferences, or tool job preferences. And if you go to databases, you can see that under this plus button, there is a something called reinforcing bars, and you can see that Robot just installed ACI 31808 without an M. Now if you click here and select the metric one and add it, then it's added, but you still have to click on it and hit the OK button or Yes button to set it as the current database. Now I hope that I don't mess up anything on camera, but if I click here, then at least I see now there we go, the grades. Yeah, the SI unit grades. Depends on your perspective. I just keep it as is. Remember, those have been explained before, so just a quick rundown. For the reinforcement pattern, this is how you define what reinforcement you have, and even you could change the shape. Some countries just put this regardless if it's needed or not. So if you change your main bar into this hooked bar and click OK and calculate the design, lo and behold, nothing will happen. Let me show you. If you go to foundation reinforcement, well, there is no dowel. Why? There is no dowel because if you go to the reinforcement pattern and to the shapes, you told him hooks only if necessary, which means he checks the reinforcement development length, and if he needs to put hooks, he puts hooks. If he doesn't need to put hooks, he will not. If you remove it and say OK, and then run the analysis again, or the calculation, then you can see that everything is hooked. Another touch that Autodesk Robot does with the foundation is that if the foundation is too... If the foundation is too rectangular, let me just force that. You just put this into one and just apply and calculate. Now this is an extremely rectangular one. Let's see how the reinforcement looks. You can see that there is, now I forgot exactly what the ACI code article was, but remember it's very clearly saying that if you have rectangular foundation, then you have to increase the number of bars in the middle third and sparse them out in the outer thirds. Now, I forgot really what it was called in the ACI code. It's been a long time since I have done this by hand, but just to mention that Autodesk Robot knows that this detailing trick exists and it does it for you, which is once again why softwares are amazing. Now, okay, let's get back to this. Oh wait, I have to hit the Enter key or the Apply key. It's kind of annoying, right? If you click on Fix and just run, it will not work. You have to click Apply or hit the Enter key for it to work. What about the loads? Well, you can see that the cases have been taken from the software, so there's nothing else you want to add here. For the geotechnical, this is where you should change things. Like for the soil, this is where you define your depth of foundation as well as the strength of the soil. You can even, if you don't like this, you can just add your own soil. If you give it the soil, then it calculates the resistance from it. And geotechnical options here. This is like what we call the middle third, basically to keep everything under compression. The stress here for the allowable is 0.30. You can change it. Now, this is something very important now. And follow me here. You might think that if you define the soil here, it will calculate the strength of the soil automatically using Terzaghi or Meyerhof or whatever. Those are, of course, theories in foundation engineering. The answer is no, it doesn't. Regardless of what you put here doesn't translate into the strength of the soil unless you go to geotechnical options, click on stress, and click on calculate it. If you click on calculate it, then whatever soil you input will reflect in the resistance. If you click on allowable, this means that something's changed here for some reason. I just canceled this. If you click on allowable here, this means that the software is waiting for you to provide it with the bearing capacity of the soil. Now, what would I do in reality? In reality, I would just write allowable here and write my soil bearing capacity here. Why? Because in reality, I get the soil investigation report, and at least in the region I'm working in, the soil investigation report also provides you with the suggested bearing capacity or the calculated bearing capacity. If this is not the case, then you can calculate using the foundation engineering courses that you've studied. Meyerhof and Terzaghi are those two equations that you should be knowing. So yeah, that's everything for spread footings. That's not the end of the video. I know I've been very late. To be honest, I have been working with the editor in trying to figure out how to model a bridge, because you have bridge series. And that's the reason why I updated to the latest robot, because we're trying to take it apart. Fantastic. So now, this is nice and dandy. However, that's not how we design foundation. Like you would think, wait, you just wasted 10 minutes of my life explaining something, and then you're telling me this is not how we design foundations. Well, I didn't waste your time because I went through everything here, so now I don't need to go through everything here, so it's a win-win. In reality, we don't do this. In reality, we group our columns into groups and we design foundations based on those groups. What I'm saying is, we don't click on each column by column and design its foundation. No, we click multiple columns and unify the foundation size of all those columns. Now here, this is of course upon the discretion of the engineer. Let me show you this in action. What I'm saying here is that we are going to group our columns together. So how do we do that? Well, just to redefine terms because I don't want you to misunderstand me. What I'm saying is we are not going to click on each foundation like this and then go to design, provided reinforcements, so and so, because that's not how real life works. I mean, imagine you hand out a drawing to the workman and the foreman, tell him, hey, you have 10 columns and each column has different size foundation. The guy will never work with you ever again. So that's not how we do things. You actually group columns together. Now, how do we group columns together? We group them, usually the groups of the foundation are the same as the groups of the columns. For example, if you have 3 column groups, then you also have 3 foundation groups. This is usually the case. In some special cases, you might have different foundation groups for different column groups. For example, here, this column might be the same group of this column, but the foundation here is different than the foundation here because this foundation is a neighboring foundation. It's an edge or L-shaped foundation here. So sometimes there are some special cases. Here, of course, remember, this is upon your discretion. You are supposed to select your grouping. You are supposed to be having an Excel sheet telling you what the groups are. And how would you do that? Like, this is a small thing. How would I group things? I would group things, of course, based on the column groupings. And in case you want a quick suggestion on how to group columns, all you have to do is to go to results, click on reactions, because reactions are basically the column loads. From those reactions, you can make yourself some groupings, like all the reactions between such and such is group 1, all the reactions between such and such is group 2, and so on. Another way of grouping columns is the traditional way of saying edge column, corner column, and middle column. I will not do this, but, well, this is one example where I tell you something, but then I rely on you for doing that. For here, I will select 2 columns for a reason. Now, you could select X number of columns. I will select 2 columns for a reason. If you select 2 columns, Robot goes into a special mode. If you select 3 columns, then Robot doesn't care. But if you select 2 columns, then there is a special mode which Robot enters. What do I mean by this? I selected 2 nodes or columns. I was saying columns, but what I meant is actually supports. I selected 2 supports, and now I will go to the design and provide a reinforced concrete reinforcement. Now here, Robot will ask a question, because it detected that you have selected 2 columns. And when you select 2 columns, it asks the question if you want to design one footing for 2 columns, if you want to design a combined footing. This question only comes if you select 2 columns. If you select 3 columns, there is no foundation with 3 columns in Robot, unfortunately. You would have to do a raft. The only time when it asks you this question is if you select 2 columns and ask it to design reinforced concrete foundations. This is a bug that sometimes doesn't appear. If you select 2 columns and it doesn't appear, then you have to reinstall Robot. I'll say no, of course, and this will open for me 2 foundations. Now look at this. I have selected 2 supports. In case you're wondering, the supports had numbers of, I opened node numbering, 73 and 63. And you can see here that this foundation is a foundation for 63 and 73, meaning that it will design the foundation and select it in such a way so that it is safe for both columns, meaning it grouped them together and it will use the controlling loads in designing the foundation. This is amazing because doing this by hand is a nightmare, especially if you have multiple combinations. I will just go to foundation view. Oh wait, I misclicked. I will click on this, go to foundation view, and run the calculator again. It will now, what you see here, 2.6. Now, I did not change anything in those options. In case you're wondering why the column neck is so small, the reason behind this is because in this, I asked him for depth of foundation of -1.5. You can, for example, ask it for negative 0.5. You can ask it for negative 1.5, and then there will be a column neck, or what's it called, a corbel or something. So you can see now that the column, now there's problems with the reinforcement inside the pier because the pier is too small and I need to select reinforcement. But the foundation itself is still okay. Let me show you what the error was. Now this is a harmless error I want to show you very quickly. When I changed the depth of foundation and ran the analysis or the calculation here, I told you there is an error. I am unable to provide reinforcement in the pier. Now, it doesn't matter in our case because the pier reinforcement is already done using the column reinforcement. So all we have to do is to use the column reinforcement and extend it into the foundation. That's not a big deal. And I think the way I was solving it is by clicking on this steel and asking it to make some dual bars and then hitting OK. Oh, it's still unable to provide reinforcement. Well, joke's on me. I have to keep trying changing the pier here, changing those reinforcements, playing around with this, and playing around with the reinforcement details in the calculation option. However, that's not my case here because I'm interested in the reinforcement of the foundation. The reinforcement of the pier is taken from the column. Remember, the column is already reinforced, so you can just copy-paste the reinforcement of the column. So we have designed our foundation, and this is a make or break moment for you. If you go to the structure, there is one very important check you have to do. So we designed our foundation, and if you refresh the foundation, just click on support and click again, this is a break point for you. You can see that, oh, it worked. Well, I was banking on it not to work. Let me see. There is no overlapping? Oh, nice. I was really hoping that there would be overlap, but there isn't. Is there? No, there isn't. But still, that's a make or break point for you to check if the foundations overlap or not. Luckily for me, they did not overlap, so I am happy. But let's, for the sake of imagination, imagine that those two columns are closer. Or maybe I have some close columns. Let me just check if I have some really close columns. Now, don't tell me those columns because those are different structures. I cannot select two columns from different structures because there is a structural joint here. So those don't count. But I don't have two close columns, right? Well, no matter. Imagine now that those two columns are very close to each other. If those two columns are very close to each other, then the foundation overlaps. Now, if the foundation overlaps, you have two options in dealing with the foundation overlap. The first option is to select the two columns and design a combined footing. And the second option is to play, if you don't want to have combined footings, is to play with the dimensions of the foundation. Let me show you what I mean. Imagine that those two things overlap. They are not overlapping, but let's imagine that they overlap. If you click on the foundation and go to foundation view, you can actually force, for example, a rectangular foundation. You can force a rectangular foundation by, for example, saying 1.5 fixed. Oh wait, that's not the, is it the direction I want? I don't know, let me just show you. I just run, I don't think that's the direction I want. Let me just show you. Let's go to structure. I think I messed up. Oh yeah, there it is. So in foundation view, you can see that I changed the width and fixed it. So what I have done is I have limited robot's ability to go in this direction. So if they were overlapping, I actually forced the separation by limiting the distance in one direction, enabling the distance in the perpendicular direction. If this is one thing you want to do. And this is something we might want to do because the third topic talks about the L foundation near the bridge. But before we reach that, we want to talk about the combined foundation or combined footing. Now, for the sake of demonstration, I'll select those two columns. And you can see how easy it is to design using softwares if you have a good model. Of course, my model is not complete, and I've told you what the things are that are missing. Please check, of course, the series to understand what other things are missing. I click OK, and this time I will accept his suggestion into making one foundation for two columns. The cool thing is that it just shows you the positioning of the two columns correctly. Now here I will just blindly run the analysis and just calculate. If you run the calculation and just calculate, you can see that the foundation result is done and the reinforcement is there. And of course, because it's a combined footing, you might need to have top reinforcement It depends on how far the columns are, but typically there is top reinforcement, and that is what has been done. Now, this is ridiculous. That's not how we do combined footings in reality. I want to tell you some things that are not being done correctly here, which requires your input. The first thing that you need to change is you need to unify the reinforcement. You can do this by going here and selecting a certain reinforcement, and then going here and selecting for the footing, the first layer and second layer, selecting same diameters. For example, you can select 6 and 16 here. So if you click OK and run the calculation again, you have forced it into using the same diameter. But that is not all. The second thing that you need to keep an eye on, so besides having the same diameter, is to have the same spacing or multiples of which, meaning that those bars should be aligned. How do you make sure those bars are aligned? Well, if you go again to the reinforcements, you can select a certain spacing, and there is a minimum and there is a maximum. And if you go to advanced spacing as bottom reinforcement, that's one way of doing it. Well, you cannot force everything as you want. You see, you either can do this by tweaking your drawings manually, or you can, for example, and that's another way of doing it, you can go here into the reinforcement, I think it's called reinforcement pattern, and instead of using the same diameter, you can just go to auto again, and you would think, but wait a minute, doesn't it just undo what you have done? Yes, now I have different bars. But you can still get away with it if you go to the advanced here and asks to have the same spacing. And if you ask it to have the same spacing, then you hit OK, and hit OK here, and run the calculation. At least you have now a same spacing, which would give you a better workable version of it. However, those bars are actually having the same spacing, but for some reason, Robot is not aligning them together. Well, that's a bummer. I thought Robot was smarter than this. Because look, the spacing is the same, but they're not aligned. Kind of strange, but at least we have our objective done. The last thing you can do here in the combined footing, and you can see how much you need to test and tweak with this, is you can even select some different things like this, or make boxes or dowels or something. Let me show you. If you click this, I just clicked here, this box thing. Hit OK, and OK here, and run the calculation again. You get something that is somehow okay-ish. I'm not really happy about this. Usually it's different. Usually, well, that's odd. Usually we have our secondary reinforcement being caged and our main reinforcement not being caged, not like the opposite. Like here he's taking the main reinforcement and caging, making a box, and the secondary reinforcement just levitating. I can just force it by going here. This is out of back and forth. You can just ask it for hooks and go for hooks and hit OK and then run again. Of course, now I have done too much damage. Yeah, okay, this is at least something I have seen. Yep. It takes some trial and error, like it takes some playing around. There is no amount of tutorials that will cover everything here, so the best way to do this is just to keep trying. There might be some problems in reinforcement distribution. Nobody cares about this because, remember, our reinforcement for columns is taken from the columns, so no need for that, no sweat. Back to the structure, our final thing I want to mention here is the foundation that is an L shape. And how do I do this? Well, if you go to front, we are going to make the foundation of this one, this column, this 79. This is a special type of foundation as well as those neighbors because those are L-shaped foundations. How do I do this? Well, let me show you. I select the support here and I'll go to design provided reinforcement for reinforced concrete elements. As usual, I just accept everything. I'm not going to go through those options. There is videos that talk about this on this channel. So I just accept everything right now, and I'll run the calculation immediately, just to show you how bad it is if you don't keep an eye on it. So let me just run the calculation and apply. Okay, wait, I think I misclicked. I think this was the one, right? Yeah, there we go. If you go back to structure, and of course, remove and open the supports because I need to refresh it. So let's remove the support ones and reapply the supports, waiting another 10 seconds. Probably will not see the 10 seconds because the editor is going to do a great job in editing my stuff. And you can see I totally messed up. Why did I mess up? Now, the foundation design itself is correct. Assuming that your inputs are correct and that you have done what you want to do, the foundation design is perfect. in geotechnical and structural terms. However, in terms of space, the foundation design is bad. The foundation design is bad because it overlaps with this column. You would think, well, that's easy. Select them both and make a combined footing. Not so fast, because those two columns are from two different structures. There is a structural joint between them. You are separating the two structures for reasons I've explained before. And since there is a structural joint, I don't know, maybe you are having different opinions, but this is what I have seen before. So this foundation is not what I want. Now, this means that I will go to the foundation first, and I'll just go to foundation view and start tweaking until I reach the thing I want. And this is something that is new. So if you click on optimization, you can see that there is something called limited by adjacent footing. And you are limited by adjacent footing. If you go to structure, you can see that you are indeed limited by an adjacent footing. And now robot needs to know how far distance it has. So I will go to tools. I think it's called dimension lines. Tools, dimension lines. 0.42. Okay, I have 0.42. Now, 0.42 needs to be divided by 2. Now, there are some geotechnical issues here. You should have the foundation spaced. If you don't have the foundation spaced, then the stress from the first foundation is going to overlap with the stress of the second foundation. We studied this in Braja M. Das's book. The stress cone is distributing in the soil in a 2-to-1 fashion. So in this place, you would have stresses from both columns. Now, how do you do this? You would have to design your foundations first and then check the overlapping stress. A good way of doing this is when you define your foundation in this foundation thing, in the soil parameters, to go to the stress and lower it down just to be on the safe side, and then double check by manual calculation. Robot doesn't realize that there are two supports close to each other, and it doesn't calculate the stress interaction between the two supports. So what I suggest to you to do is to go here, stress, reduce it, calculate your foundation for both columns, and then manually check the stress in the place in between the two foundations. So let's go to the foundation view now. We are limited in the x-axis by an adjacent footing, and it is from the right. And the distance, dx, is 0.21. And I'll apply that. Wait, what? Oh yeah, I know why. The foundation is too large. I'm telling it that there is something adjacent, but then it realized that, yo, your foundation is too large. How are you telling me there is something adjacent? Like if you say here, look, the current dimension is 1.9, right? The half of it is 0.95. If you go here and say 0.5, it will tell you too low. If you tell it exactly 0.95, it tells you, okay, you are right. Because it accepts your notion that there is a boundary here 0.95 meters away from the column. But the boundary is not 0.95 away from the column. So I have, first of all, to make my foundation small. Let's just put here 0.42 by 0.42. This is just a dummy value now. And now, wow, I don't think this will work. I'm pretty sure that the foundation will not work. Now I'll go here to say, I think it was 0.21, right? Now it accepts it. Because the distance here is at least half distance here, or maximum half distance here. I'm pretty sure it will not work, and there will be some moment problems. Oh wow, look at this. This is a joke. What am I looking at? That's just impossible. If I go to foundation, let me see why. Yeah, of course, there's a huge moment, right? Wow, look at this. This is a joke. This is a bloody joke. Okay, how can we improve that? It's too large. I'm pretty sure this is incorrect. There is something that is not working. I think I know why. I will tell you why. So if you go to foundation view, of course, it designed a crazy foundation because it needs to abide by what you have given it, which is like, it even gives you yellow, like, are you sure about that? Let's go to, I think it's in geotechnical, right? Not in soil, in geotech. There we go. In geotechnical, there we go. The contact surface was limiting the thing because it tries to keep the resultant force in the middle third. So now let's just give it some freedom in doing it and see what happens. Oh, no, it got smaller. Who am I kidding? It's still large, but I mean, it's twice as small. Okay, what's the foundation results? Wait, are those values even right? I never thought about this. Wait, what are the values in geotech? You know what? Let's calculate this. Let's give it calculated. I think this is too much. 3.7. Let's see. It looks like garbage. Now here, this is where the tricks and tips in real life come into play. There is something called, what was it called? Like you could have a L-shaped footing and a beam between two footings to decrease the instability of the L-shaped footing. I forgot what the name is. My. If Dr. CE was here, he would immediately know, but I totally forgot. That's why they call a noob. I'm pretty sure that the editor CE will show me the way. This is ridiculous, and it's kind of annoying that this got that embarrassing. Well, worst case scenario, I would do a raft for this. But well, topic of the day was to show you how to design foundations and how to implement some ideas in your structure. I'm pretty sure you will not be faced with such a crazy thing, but if you are faced, then you know what to do. Worst case scenario here, I would make a combined footing, or I would just apply a beam. I think it's called a backbone beam or something, where you have a beam between two foundations. I'm not happy about this foundation, but remember the point of this is a tutorial, so what I suggest you do now is to dive deep and try your best and try everything you want here. Maybe you can give me some suggestions in the comment section what you would do. I would definitely highlight those comments and even engage and talk about them in the next video. I am pretty active in the comments. Usually 2 days you will get a reply. So yeah, that's everything I wanted to talk about today. Spread footings. Next time I might be talking about raft foundation, and if I can, I will be talking about pile foundation. So yeah, that's everything I wanted to talk about today. I hope you enjoyed the video. And with that being said, and before I finish, I want to give a combined footing sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support for the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and that it was beneficial for you. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.